Yeah, so this demo takes our demo from last week just one step further. I have just tap water. It's just at room temperature. And then, I don't know if you can see, this is clearly labeled salt water, which I mixed up last night, also at room temperature. And I'm going to add a drop of food coloring to each. And last time, remember, we had hot water and cold water, and the food coloring dispersed more quickly through the hot water. You guys remember why that was? You can turn your microphones on. Why did the food coloring disperse more quickly through the hot water? Please turn your microphones on. We're learning about physics and motion, and we were talking about the motion of the particles. And hot particles move faster than cold particles. So the water particles actually are in constant motion. And when they're hot, they're moving faster than when they're cold. So that's why the food coloring dispersed more quickly through the hot water than the cold water. But today I have just plain tap water and salt water. What do you think is going to happen? Well, we shall see. So this is tap water and this is salt water. And that's just room temperature, both of them. I mixed up the salt water last night to make sure that would also be room temperature. You can see that our room temperature tap water is kind of acting like the cold water a little bit, but it's starting to disperse. But the food coloring in the salt water is just sitting at the top. Any ideas why that might happen? It's not moving at all. It's spreading over the top. I don't know how I can show you. I can show with this one just sitting on the top. Maybe I can bring my computer over so you guys, I'll try tipping it so you guys can see that it's just at the top. Oh, trying. Without knocking other stuff over. Just sitting there. And that's due to another property of matter known as density. I'm sure you guys have studied density before. The salt water is more dense than the food coloring, so the food coloring just floats on the top. Okay.